All of our body fluids are primarily water. Taking a look at this picture, we can see that we have water making up the cytoplasm inside of cells. That's referred to as intracellular fluid, but that's just cytoplasm. And then, of course, we have fluid outside of our cells, like interstitial fluid, if it's not part of the blood, or plasma, if it's part of the blood. Those components make up extracellular fluid. And together, the water that's outside of our cells and inside of our cells makes up the total volume of water that we have in the body. And so the story of water balance really is a story of making sure that we have enough intake to balance the output. And so you can see that we lose a certain amount of water each day, and then we have to take in at least, an equal amount to make up for that. So humans have an obligatory water loss. We're unable to excrete urine in a solid form like some other organisms. And so because of that, even if we were, say, like stranded without water, this output could go down to like a little under a half of a liter, but you couldn't get it under that, which means that you must have intake. And so as far as water balance goes, it's hormonally regulated as far as preventing our body from becoming too concentrated. So for instance, we know if the extracellular fluid becomes salty, right, becomes concentrated, then it's the hypothalamus that would detect that, and the hypothalamus can initiate a feeling of thirst. But more than that, what can happen is if our blood becomes salty, so to speak, an increased sodium concentration, that the hypothalamus, in addition to making us thirsty, can stimulate the posterior pituitary to release ADH. And we know ADH will target the kidney, and it's going to increase water reabsorption at the level of the kidney. And so when you take water back into the body, that's going to increase our plasma volume and decrease the urine volume because we're taking it out of what would have formed as urine. And so the classic problem with water balance is dehydration. Because we're losing water from many different sources, many different places, right? So maybe we are sweating too much, or maybe it's just a hot day and you're not drinking enough, or maybe you're sick and you're vomiting, or losing excessive water through respiration, what have you, lots of reasons that we would lose too much water. What happens in the body is when we lose water, what it means for the osmotic pressure to rise is that as that water leaves, it makes your extracellular fluid more salty, right? And because the extracellular fluid becomes more salty than the cytoplasm, than the intracellular fluid, what you have is you have a water gradient. And so water will move from its area of high concentration into its area of low concentration. So again, I'm looking at the water gradient. So if I have low solutes, I'll have a high water concentration. If I have high solutes, then I'd have a lower water concentration. And so water moves by osmosis from its area of high to low. And when water moves, you can see that they're showing us in the picture that the cells shrink up. Okay, and that's what dehydration is all about. Looking at the opposite problem, and much more rare problem, there's a problem called hypotonic hydration, also known as water intoxication. And this is when a person drinks an excessive amount of water in a short period of time. Why would that happen? You hear of this sometimes with contests or with sorority or fraternity hazing, pica. So there's some different reasons. Oh, and another reason would be diluting baby formula. That's one of the most common things that you would see. So if somebody takes in a lot of water over a short period of time, it does the opposite. What it will do is it will dilute out our extracellular fluid, right? The osmotic pressure falls. In other words, we have a lot of water out here, high water concentration. We diluted it out with all that water intake. And so what happens is you have less water concentration in the cytoplasm, and we know water will move from the area of high concentration into the area of low concentration passively by osmosis. And so when water comes into the cells, it literally will swell the cells. And if you swell cells of vital organs like the brain enough so that they stop functioning, that could be have long-lasting effects or even be fatal.